we have already seen different types of data usage and different types or different levels of data analytics. Majority of the transaction, so one types of data usage is OLTP, and another type is LLAP or OLAP. In the beginning of database development history, the databases are used for transaction. Mostly for most of the transaction. And people start, as we have more data, people start to run analytics on the transactional databases. However, it turns out transactional databases are not really suitable for data analysis. So this not suitable is reflected in many different levels. For one thing, tables are designed to be relational and small and narrow with less columns. They are aimed to provide the fast operation for insert and update and delete. They are not dimensional. They are not providing us with the fact dimension star schema, which is another issue that the schemas are designed as entity relationship the model. You have a complex Crawford joinings and relations. They are not really star snowflake. It's hard to perform dimensional analysis on top of this entity relational model. And also, database is optimized. Transactional database is optimized for fast writing of small current data. They're not designed for long querying of historical data. So for this reason, as time goes, people start to realize that you need to have a separate place to store your data in the format that is suitable for data analysis. This place is called data warehouse. It contains fact table and dimensional table. It was designed as a star schema, snowflake schema. So the tables are dimensional and they can be, they may not be first, the second normal form or third normal form compliant, but still they serve the purpose of a fast join between fact table and the dimensional table. And they use the star schema and the snowflake schema for lookups. And the database themselves, the joins, the indexes are designed for complex query, complex reading, long-term reading and historical reading. So this is what we call data warehouse. Data warehouse usually consists of three stages, or maybe sometimes people just say it's a one stage where you have the cleansed data inside. But usually data will come from sources, right? And different sources, different operational sources, different transactional sources will feed their data into a staging area. It comes into a staging area first, where because data from different sources may not have may not be conforming with each other. For example, a health insurance company may have a source of pharmaceutical claims and dental claims and the vision claims and medical claims, right? And apparently someone going to dentist, someone going to vision may not be the same one who goes to vision. So when you go to look at the patient or member or insurance member database, someone only have vision record, someone only have a dental record, someone only have pharmaceutical record, right? So this is not uncommon. Different sources will provide us with different data aspects, even if the object is underlying entity is the same. For the same customer, right? For the same member, you have a dental or vision, and they may be overlapping. Someone can both goes to dentist and go into optometrist. But it's possible that some of the records are not overlapping with each other. And in order to consolidate all this into one data set, that we can get both both vision and dental information for the same member, for all the members. We have to use some method to extract the data, to compare the data, to consolidate the data. But during this process, you will need a staging area where you will place the intermediate result there. This is where we call the staging area. And the process loading is called ETL, extract, transform, and load. After this step, when the data from data source are cleansed, consolidated, aggregated, we will place them into a data warehouse. Now, data warehouse is useful. It contains all the information, but it may also have certain data marts. And on top of the data mart, you will have OLAP or BI applications running against these data marts. The whole data warehouse architecture looks simple, but implementing that can take a long time and requires some systematical approach. The most common way, the most common approach of building a data warehouse is developed by someone called Ralph Kimball. I happen to run into Mr. Campbell before in some industry conferences, and the approach he developed is called Kimball methodology. I think there are a whole bunch of books written by Kimball and Mr. Kimball and his friends, his co-authors. So you can Google Kimball data warehouse books, and you will find all of them. Now let's talk about data mart. Data warehouse is huge, right? Usually data warehouse is huge. It contains all the information your database, your enterprise generates. And for most of the analytics, you don't need all of them. And sometimes, a lot of times, you only need a part of it. You only need a part of like, for example, you only need if you are from a health insurance company, you only need to look at the active members. You only need to look at the past 2 or 3 years, right? These are the things, these are examples of how you only need a subset. So instead of running against the whole data warehouse, you can also create a data mart, which is a subject area of data warehouse, combines a smaller subset of tables, like only containing maybe 10% of the table, and it does not contain all the historical data, right? Some tables, like member data, may be shared across different data marts. Usually these are the lookup tables, the dimensional tables. They may be shared among different data marts. And each team will run against 1 or 2 data mart, or maybe 3. Different people have their own different data mart. Now, the problem with data mart, the advantage of data mart is it is fast. It is fast in the sense that it's smaller, right? So it's easier to implement the data mart. And it's easier to, even when there's no data warehouse, before data warehouse is built, or during the process that someone is building the data warehouse, you can have your data mart up and running first. So this is not uncommon. Even Kimball himself mentioned that a lot of times data warehouse don't fall from the sky. Instead, different teams build several data marts, and then eventually these data marts get integrated together and form a data warehouse. This is also a possible approach. But if implemented poorly, different data mart can have a conflicting data. And this is much common than you may thought. I'm pretty sure you will run into it sooner or later in your professional career. Some data marts are having different data than the other, and different teams fight over which data mart is more correct. But usually this is because different teams implement different data mart, and they have a different source and different logic. There's no good way of a quick and easy way of fixing this issue. It really, if you run into this kind of issues, remember this requires a data architect, a team, someone from upper management to make a decision that they need to, that the company need to resolve this issue by comparing and contrasting data mart table and figure out the correct data, the good data that everybody should follow, which is called the golden record. There are some other terminology you may hear of. One is the ODS, or operating data store. Operating data store is actually the database with transactional data, but these transactional data are different from the sales transaction data we are talking about. Transaction data like sales or like UPS delivery, these transaction data like sales or like social, let's just say sales. Okay, these are time sensitive, and you need to handle, or stock transaction, right? Stock transaction. These are time sensitive, these are small, and these are usually, this data processing usually requires fast response. So you cannot really run huge queries on them. But there are also a type of transactions that is not so critical of performance. For example, social network. If you post a post, if you post some comments, it's okay to wait for 10 seconds, right? It's okay to wait for even 30 seconds. If the website is busy, if everybody is talking about the same thing, sometimes people just wait for 1 minute till the web page show up. So these transactions are not so performance critical. You can have a slower performance. You can share the table between the transactions and the data analytics. In this case, or another example is a custom service, right? You call a credit card company or a phone company. Oh, I have an issue with my credit card, or I have an issue with my home network. They will reply to you. They will work with you. They will type in, but you do expect some delay. If the home network doesn't work, then waiting for 5 minutes is not a big deal. So these kind of things allow some delay, allow some performance hit. So instead of copying all the data out and dump them into a data warehouse, some company actually runs their query on top of the ODS, but they are different. They are still there. Systematically built ODS is different from a traditional transactional database in that they still have some lookup tables. They follow some relational design principles and some on top of that, add some dimensional lookup tables. So this is what you see at ODS. It's a transactional. It has the most recent transactional data, but somehow you use them for analytical operations. And in order to do this analytical operations, some people also add some lookup table and dimensional table to enhance its performance. It's somewhere between transactional database and data warehouse. So this is something that you will also run into. And also there's something called logical data warehouse. If the transaction is just on top of one table, it's also common that in addition to the entity relational model, you add dimensional tables and directly use the transactional table as a fact table. This is what we call a logical data warehouse. It was popular at one time when when large data storage was very expensive. But these days, it becomes less and less. And now, for you as data analyst, data scientist, data warehouse or operating data store will be the #1 database you will be accessing. You most likely will be running CR/SQL against this data warehouse and operating data store and some kind of a data mart. But in addition to these databases, there's also something called data lake these days. So today's data volume is so large, like dumping everything into a data warehouse is not practical. This is partially the reason that the ODS, what we mentioned just now, ODS and the logical data warehouse was invented, because the volume is so, data volume is so large, it becomes prohibitive to create another data set that is equally large. Just moving the data itself is a daunting task. So some people try to resolve that by running query directly against the fact table in directly against the transactional tables, which is either ODS or logical data warehouse. And meanwhile, we also notice that most of today's data sources are relational. If you look at most of the data sources, the data feeds, these days there are more and more text fields, text files coming in, which will be looking just like a relational data set, maybe with some change, but usually this can be considered relational, or at least you can apply some relational data operation to it. So the solution is, instead of dumping every data, all the text files into a data warehouse, we will treat these text files as if they are database tables and directly query them using SQL. And remember, in the very beginning, of this class, we mentioned that in the early days of data warehouse, in the early days of database, people used files to store data and perform analysis on files. So we are going back to the same way, the same approach that we work directly on the files, but with a more advanced technology. These days, we are doing the same thing with more advanced technology. Instead of uploading all the files into data warehouse, we just query directly against the text files. And the collection of these text files, we call them data lake. The data lake will contain all the files from source. These are raw data without formatting, without extracting, without cleansing, but they are relational and you can run SQL against it. Data lake analysis is appropriate for those requires less accurate outcome. Like if you just want to see a general trend, you just want to see you want a fast look at the general trend or a current trend. Like in the last 5 minutes, suddenly the stock price have a nosedive. Whether it's a nosedive of 50% or 51.3%, it's not so important. The important thing is it has a nosedive. Then it's ideal for data lake. You look at the text file, you look at the data coming from the source, and you see the trend. That's all it's important. All it matters. It's fast. It didn't even go through the step of going into data warehouse. You just look at text file, you see the dive. So this is what you can do with the data lake. But on the other hand, still data lake is not clean. Data lake data is not clean. So usually what's happening is you will have a data lake and you will have a data warehouse. You will load the most critical data into data warehouse. But for the majority of the data, that is like one time, you probably will not load them into the data warehouse. You probably will still aggregate them. An example is like in Twitter. There are so many, how many tweets are coming out every day? I don't even remember the number, but I can say with confidence, like 99.99% are junks. Nobody cares about this after 5 minutes. Even the author will not care, right? Even whoever writes that. So what's going to happen is you can put these tweets in data lakes, in text files. And if you want to analyze them, use your SQL to analyze as data lake. But if there are something that truly important, like some statistics, you can calculate those, aggregate them, and dump this into data warehouse. This will be a much smaller data set, but those are verified and cleansed and verified data that are worthwhile to be stored in the SQL database. So this is what we call a data lake plus a data warehouse. Sometimes you hear people talking about lake house. This is what the data lake is about. So these are different components of a data warehouse. You see that we have a staging area where you have the data from data source, you have the data warehouse, and you have a data mart, right? Data mart is a small subset of a data warehouse. Then because data warehouse implementation is difficult, so we come up with alternatives, ODS, logical data warehouse, and data lake. One more thing is about ETL. How do we move data from source to staging area, from staging area to data warehouse, and the data warehouse to to data mart? We use ETL. ETL is the acronym for extract, transform, and load. And usually you will run this in an automatic way, usually from a client tool. You will use some native tool like SQL, pSQL to run SQL store procedures. And by the way, this is the #1 usage of store procedure and functions. That's when you use a lot of store procedure for data loading. Also, you will do customized tools like using Python or using Java to write some of your own code, your own processing logic, so that data are moved from one place to another. And when you load the data into data warehouse, you have a cleansing. You're not only doing extracting, you're also doing some transformation and some aggregation and cleansing.